Okay, let's take a look at this. We'll go over this, the sample test. Number one is to solve that differential equation, dy dx is x squared. And what we want to do is separate the variables.
You're clicking again.
Oh, am I at the top? Okay. Okay. All right, so dy is equal to x squared dx. Integrate each side, or find the antiderivative. This is y, this is x cubed over 3 plus a constant. And since there's no initial condition, that would be your answer. Okay,
Do
that
we
would
have
be
to write all the steps in the
no,
list? Or
no. It's a multiple choice.
just multiple choice?
Yeah, so one of the answers will be this one. Okay, it is rare that there will be an E answer. So rare that if you get an answer that's not listed, you really want to check your work because it's very rare there is an E answer. Okay, so that would be the answer. Number two. The derivative is cosine. We are given an initial condition which will enable us to solve for the constant. Separate the variables. Integrate each side. Integral cosine is sine. And we want to make sure that this contains the point 0, 0. So, y is 0. When x is 0, solve for c. Well, sine of 0 is 0. C is equal to 0. C is equal to 0. The solution is y equals sine x. Y equals sine x solves the differential equation and contains the point 0, 0. Okay? Any questions on those? So you'll be given a couple of differential equations similar to these, the kinds of things we saw right off the bat, for like first or second class or something. Okay? If you have a question, let me know. All right. Number three, find the average value. Average value is 1 over b minus a, the integral from a to b, f of x dx. What you are doing here is finding the height of that rectangle whose width is b minus a and whose area is the area under the curve. Okay? That's the average value of the function. In number three, we've got the square root of x from 0 to 4. Well, that's 1/4. This is x to the 1/2. The integral is x to the 3/2 divided by 3/2, which is multiplied by 2/3. Okay, 2's, you got a 1/6 out there. Put a 4 in, 4 to the 3/2, 4 to the 1/2 is 2, 2 cubed is 8, 0 is 0. We end up with 4/3. Okay. That's the average value of the square root function over that interval from 0 to 4. Okay. 4 is 1 over x. Average value. And we're going from 1 to 2, so the average value would be 1 over 2 minus 1. 1 to 2, 1 over x. This is just plain 1. That's the natural log of x. Natural log of 2 minus the natural log of 1. But the natural log of 1 is 0. You get the natural log of 2. The average value of that function over that interval is the natural log of 2. Okay? All right. You all set on that? Caroline, are you okay? Number 5. Whoa, what's wrong? What happened? Ln 2. Number 5. Tangent x, average value. Tangent over that interval from 0 to pi over 4. Well, 1 over pi over 4 is 4 over pi. The integral of tangent is a negative natural log cosine. Boy, this is a pain in the neck. Negative pi over 4. The You put in pi over 4, the cosine of pi over 4 is square root of 2 over 2, so the natural log of square root of 2 over 2. Minus, substituting 0, the cosine of 0 is equal to 1, but the natural log of 1 is 0, so forget about that. That would be your answer.
You're off.
I'm off? I've heard that before. All right. Okay. And you may protest and say, whoa, over that interval from 0 to pi over 4 tangent is not negative. This looks like a negative answer. How can the average value be negative if the tangent is never negative in that interval? But this is not a negative answer, okay? Natural log of square root of 2 over 2 is a negative number times another negative number, which will give you a positive number, okay? So it's okay. All right, everybody all set on that? Yes?
Does that say ln cosine x1?
That says ln square root of 2 over 2.
Before.
Before, natural log absolute value of cosine x. That's the integral of tangent. Okay. So Hanley Ramirez is already there. 6 days early in camp. Fort Myers. 15 pounds lighter. Ready to go. I'm psyched. I'm psyched. All right. Now I just threw that in there. Okay, we all set on this? Okay. Number 6. First step in evaluating the integral. Well, this integral is, I know, I usually, all right. I got to get this, I should have an outline or something here, but it changes all the time depending on how you set it up initially. All right, but anyhow, square root of x squared plus 3x plus 6 over x plus 5. First step is to do what? Long division, divide. One of the answers would be divide. And that's what you do. That's what you do first in this problem. Divide. Long division.
Oh, you want to know literally.
Yes. I want to know the first step. Find the first step. First step is to divide. That would be your answer in this question.
So you didn't need
What? What are you guys saying?
We all took the integral.
It says find the first step. You don't even have to divide. It just says, well, I said find the first. You guys got a case. You have a legitimate case. But on the test, let me just tell you this, Monday's test, if you have this question, one of the answers will be divide, and that is the answer.
Oh.
Could we solve this though now?
You want to? Let's do it. We can do it.
That would be nice.
All right, x squared plus 3x plus 6 divided by x plus 5. Okay. What times x is x squared? That's an x. Put that right over the x column. Then subtract. These cancel. You subtract and bring down the next. What times x is a negative 2x? Yeah, minus 2 is what you would put there. Negative 2 minus 10. And subtract gives you a 16. Okay. What happens is this integral becomes this integral. X minus 2 quotient plus remainder over divisor. No, you're not adding these two, you're subtracting. You're taking 6 minus a negative 10. Okay? What's this integral? Well, the integral of x is x squared over 2. Integral of 2 is 2x. Now, what integration form is 16 over x plus 5? What form is it?
16 ln x plus
Yeah, that's exactly what it is. It's a 1 over u du form. That's the form it is. 1 over u du form. U is x plus 5, du is dx. No need to multiply by anything. 16 natural log absolute value x plus 5. That would be your answer. Okay? That's the integral. But I'm only going to ask for the word divide. So there you go. Okay? First step in number 7. Yes, exactly what the first step is. The first step is let u equal x plus 1. Okay? Okay, that's the answer. You let u equal x plus 1. If I asked for the form, what form is this integral? What's the answer to that question? No. U to the n form. Okay, it's u to the negative second du. Okay, it's u to the n form. If the 2 weren't there, Chris, you'd be totally correct. Okay. 8. Oh, 8. What is the first thing you should do in number 8 to do this integral? Yeah, you let u equal what, though, here? The square root of x plus 1. You want to change this integral. This is not an integral of any form that we have. This is one of those, what's called a further substitution. You let u equal x square root of x plus 1. You square both sides. You solve for x. You solve for dx. And then make a substitution back. And what happens is you've eliminated the square root, which enables you to do the integral. Okay? This is the first step, is to let u equal the square root of x plus 1. Yes?
Could you show us?
Yeah, let's do this. Okay? Let u equal x plus square root of x plus 1. U squared is x plus 1. U squared minus 1 is x. 2u du dx. Yep, okay. That's the way. Let me know. Is equal to 1. So this tells me that 2u du is dx. Now what you do is substitute back into the original for x, u squared minus 1. Okay. Square root of x plus 1 is u. Dx is 2u du. Okay. Now what do? You multiply the thing out. You can take the 2 out front. Get a u squared times u, u to the 4th, minus u squared. And this is an integral you can do. There's no square root, okay? You've eliminated the square root. When you integrate this, you get 2. This is going to be bad. I can see this right now. Okay? When you integrate this, you're going to get 2 u to the 5th over 5 minus u cubed over 3 plus c. But I got to tell you, that's not how it should be left. Because you started with x's, you should end with x's. You should replace this u with the square root of x plus 1, which is x plus 1 to the 1/2. So this is x plus 1 to the 5/2 over 5, x plus 1 to the 3/2 over 3 plus c. Okay? And believe it or not, there's some algebraic things you could do with this thing. You can combine them into 1 by putting them over 15ths. You can also factor out an x plus 1 to the 3/2 out of each of those. But let's just leave it at that, okay? So on the test, you have to come up with this answer. U is the square root of x plus 1. That's what the answer is. If you had to actually do the integral, this is what you would do. Oh, Caroline.
For number 7, the answer was substitute, or?
The answer was, in number 7, to let u equal x plus 1.
Oh.
Which is a substitution.
Which is a substitution. But I specifically have let u equal x plus 1. I have another answer there would be to let u equal x plus 1 squared. That's incorrect. Then I have another thing which is divide. That's incorrect. And then I have another answer is, first thing you would do is, I don't know what else I have for an answer. Look at Lewis's paper. I don't know if I have that as an answer. I probably don't, but there'll be another answer down there. Okay, that's not correct. Okay. All right, are we all set with that? Okay, that's number 8. Let's keep on going. Number 9. All right, 9 through 14, you actually have to do the integrals. So here we go.
But it's not asking for the average Right.
For number 9?
For 9, just integrating.
Just integrate. Just do the integral. Okay, you ready? Let's do it. 0 to pi over 4, 2 sine 2x. What form is this? Sine u form. U is 2x. The du is 2dx. You have it already. I gave it to you. Free of charge. So we have a sine u. The integral of sine u is negative cosine. 0 to pi over 4. Substitute in. 2 times pi over 4 is pi over 2. The cosine of pi over 2 is 0. Minus. Cosine of 0, and the cosine of 0 is 1. The answer is 1. Okay. That answer is 1. Okay. Any questions on that? Number 10.
Why was it negative cosine?
Because the integral of sine is negative cosine, I will typically take any constant out front and leave it out front. You could bring it in there and deal with it twice, but I think you're better off taking it out once out front. The integral of e to the 2x dx. What integration form is this? E to the u. U is 2x. Du is 2 dx. Not a problem. We can do that. Multiply by 2 and by 1/2. We get 1/2 the integral. X is going from 0 to 1. E to the u du. I specifically said that x is going from 0 to 1 here because I changed it to e to the u du to show the form. The limits of integration, however, are x limits. So when these are different from the variable, you should specify. It's not a big deal, but that's what should be done. Now, what's the integral of e to the u? Same thing, e to the u, so it's e to the 2x from 0 to 1. See, what you could do in this integral, this definite integral, is change the limits of integration to be u limits. We're going to do that later on, okay? It's not a big deal with these simple integrals, but later on when we do more complicated ones, it's something we'll do. What's that?
Defining the x as defining the
Yeah. So, we get 1/2 e to the 2x, that's e squared, minus e to the 0, which is 1. That would be the answer.
How did you get the 1/2?
The 1/2 comes about because in order to get du of 2 dx, I had to multiply by 2, but I can't just multiply by 2. I have to compensate by multiplying by 1/2. And that way I could substitute the du for the 2 dx. And the 1/2 stays. What happens to the 2? It's in here in the du. Okay, 11. 0 to 1. 1 over x plus 1 cubed. What form is this? U to the n form is correct. You're letting u equal x plus 1. Du is dx. No need to even multiply by anything. We have the integral from 0 to 1, u to the negative third du. Okay. Add 1 to the exponent, you get u, which is x plus 1, to the negative second divided by negative 2. Okay. Everybody okay with this? Everybody's all right? Yes?
Are they all like u to n power forms, or?
Yeah, these are typical. What you see on the test is very similar to this.
What happened to C-man?
On definite integrals, we don't need them.
Are these,
These are all going to be definite integrals.
because the boundaries are defined.
Wait, maybe not. Hold on. No, there is number 14. The cosh function is not a definite integral.
okay.
All right, so let's evaluate this. You got a negative 1/2. Stick in a 1, 1 plus 1, 2 to the negative 2 is 1/4 minus, substitute in 0. 0 plus 1 is 1. 1 to the negative second is 1. You end up with negative 3/4 times a negative 1/2. That's a 3/8. Okay. And that's the answer. Okay. How are we doing? All righty. You doing okay? Amanda, you doing okay? Number 12. The integral from 0 to 1. 1 over 4 plus x squared. Ooh. What form is this?
Inverse tangent.
You bet it is. Okay? This is an inverse tangent form. And it's our generalized inverse tangent with a squared plus u squared, where u is x. What's a in this case? 2. Therefore, it's 1/2 inverse tangent x over 2 from 0 to 1. It's 1 over a inverse tangent u over a. Okay? Substitute in 1. Inverse tangent 1/2. What the heck is the inverse tangent of 1/2? Does anybody know that? No, nobody knows that. That's inverse tangent of 1/2 minus the inverse tangent of 0. What's the inverse tangent of 0? 0. So we got 1/2 inverse tangent of 1/2. Okay. Yeah, that's it, right? Yeah, that's it. That would be the answer. We okay on that? That's 12. Holy man. It's going to take weeks, hours, and hours for you guys to do this test. 13. We have the integral from 0 to 1/2. 1 over square root of 1 minus x squared. What form is this?
Inverse sine.
Inverse sine. Very nice. It's straightforward. Inverse sine. So you get inverse sine of 1/2 minus inverse sine or arc sine of 0. Now see, something like this, I would expect you to know inverse sine of 1/2. I would not expect anybody to know inverse tangent of 1/2. Who knows what that thing is? But for these something like inverse sine of 1/2, I would expect you to know that. What angle has a sine of 1/2?
30?
It's at 30 degrees.
Yeah.
You have to have it in radians.
Pi over 3?
No.
6.
6. Pi over 6. That would be the answer that you would see. Okay? Now that would be the one time you may need a calculator. The problem is most calculators, scientific calculators at least, won't give you pi over 6. They'll give you 0.57, whatever the thing is, as a decimal. So just be aware of that. You should know the inverse sine of 1/2, though. Okay?
Some most scientific calculators have a rating on
Yeah, maybe, huh? Maybe. Will they give you the pi over 6 answer? Maybe. Some will. I know some will. Well, all? I don't think all will.
Usually a radian of.
If there's a radian mode, even that.
You can change it between radian and degrees on most.
Yeah,
It's
yeah,
It's
yeah.
still a decimal.
It still gives you a decimal. That's my point.
Well, mine gives, yeah.
Oh, maybe yours is not going to be legal then, Jacob.
Well, it depends on what it is, though. Sometimes.
Let me see that calculator. What kind of calculator is it? Oh, that'd be okay. You could use that.
It just, I mean, a lot of other calculators have it too at the button.
Yeah,
It lets you go
yeah,
decimal
you
to-
could use that. That'd be fine. Okay, 14. Wow, we're getting here. Integral of cosh
Cinch.
is sinh, but you got to be careful here. What form is it? Cosh u form. What's u? Du? Very nice, thank you. So you got to multiply by 4 and by 1/4. Okay.
I have to go deliver a grilled cheese to Connecticut.
That's okay. Whatever. It's your call.
I'm not even joking.
It's okay. Hey, whatever.
Maybe it's like a code word for drugs.
Oh, is that what it is? Oh, that's probably one of those latest designer things. Never mind. Okay, no. What's that?
You're up to the side.
Oh, I am?
Okay.
All right, there you go. Okay, so we have to multiply by 4 and by 1/4. You end up with 1/4 the integral of cos u du. And the integral of cos is sinh u, which is 4x.
What do you call it?
This is cos, this is sinh. That's how it's pronounced. Okay. This will be the answer.
Is it cinch with a CH or you just pronounce it cinch?
Yeah, I pronounce it sinh.
Otherwise
No,
you'd
but
say
that's standard.
sin HX.
What's that?
Otherwise you'd say sin HX.
Yeah, I know.
Cos HX.
Yeah, it's not good. It's sinh and cos. You're going to have to trust me on that, Amanda. Okay? All right, 15. Oh, give the integration form. All right, here we go. This is good. You get to this point, you're just about done. All right, the integration form of this one, x over 1 plus x squared dx. What is the integration form for that? U to the n is not going to be acceptable here. What is this?
Inverse tangent.
No, it's not inverse tangent. If you didn't have an x up there, it'd be inverse tangent. Karen. Well, U substitution applies to virtually anything. You're going to have to be more specific than that.
I don't know what kind of answer you're looking for.
What's that?
I don't know what kind of answer you're looking for.
I'm looking for an integration form that we have. We have a list of about 12 integration forms. And one of those forms is what this one is.
1 over u.
Yes, it's 1 over u du form. That's the answer. Okay? 1 over u du. All right? That's the answer to this question. That's a 1 over u du form. U, here, let me do it out. U is 1 plus x squared. Du is 2x dx. Oh, we have an x. Good. Multiply by 2 and by 1/2. 1/2 the integral of 1 over u du. That's what you end up with. And you can make an argument for u to the n form, but don't, okay? You're going to lose that argument because that 1 over n, 1 over u. Let's see, 7:30. I start. All right. This 1 over u du form, okay, is not really a u to the n form where n is -1. The u to the n form is for everything where n is not -1, okay? This is specifically for that case when it is -1. So 1 over u du form is what's on the test.
ln of u.
Well, that's the answer, but I'm going to ask for the form. So what the test answer is going to be, I think I have it just like this, 1 over u du. I think that's how I have the answer. I may have this, or I may have this. I'm not sure what I have for an answer, but it's one of those. It's 1 over u. Okay? And I'm not going to put this and this and this in an effort to trick you. Okay? So it's going to be one of those. All right?
What would be the correct answer?
One of those, whatever one that is. All right? I don't know which one it is, whatever I have down there. I'm not sure how I have that down there. 1 over u du. This is what I always say, though, so I suspect it's this one. Okay. I'll watch it be this, and then you guys are all going to yell at me and things.
How does 2x translate to, how do you get the 2x to translate to 1 from the du form?
Because 2x dx is du. This 2x dx is in here in the du. That's what that is. This 1 comes about because it's just like this. Yeah. Okay. 16. The integral of x squared square root of 1 minus x cubed dx. Oh boy, what form is this?
Inverse sine.
No.
U to the N.
U to the N is correct. What's U? 1 minus x cubed. Du is a negative 3x squared dx. And that's fine because we have the x squared up there. Multiply by negative 3, negative 1/3. End up with negative 1/3, the integral of 1 over u to the 1/2 du, or better, negative 1/3, the integral of u to the negative 1/2 du, a u to the n form. Okay?
And how's the answer going to look like on the
I think, Amanda, it's going to be, I think I have u to the n du. I'm not sure. I have the test. Oh, wait. Do I have the test here? I may even have the test here.
You can give it out if you want.
I am.
Take home test.
A take home. Yeah. No, I don't have it here. Nope, that would have been nice, but I don't. Nope.
Or you do, but you just don't want to say it.
No, I don't have it here. I would tell you, Amanda, if I had it here. But I'll tell you, I know where it is, though. Okay, hold on. Hold on. I got to get connected here. Hold on. I will tell you the form in a second. Okay. I will tell you very soon. Yeah, I know. I'm just trying to get on the wireless thing. Jimmy,
Can you get on wireless?
come here. It's whirling around. It's whirling around. It's not doing much for me, though. When I need it soon. Okay, I'll tell you what. I could get wired here because there is a cable, isn't there?
Yeah, there's a.
There's a cable somewhere.
Yeah, but I don't think it'll fit in yours, will it?
Sure. I don't see it. I don't see it. How come it's, wait, a problem, look at, a problem occurred. Okay, hold on, maybe I can get there. Maybe I'm
Why
already
don't you go to
connected.
405?
Because does that would mean walking down there and bringing
Oh, I
them
know,
to
that's-
class? And how much
That's tough.
room you got over there?
No, 405 is, I don't, there's nobody in there.
Oh,
And it's got the both of them.
really?
Yeah.
And I don't even see my Dropbox on this. That's because Mathematica uses up too much room.
Oh.
But I hate to quit Mathematica because then I wouldn't be able to do the lab. Who's on wireless right now?
I was.
Amanda, you on there now?
Oh, yeah.
Yeah,
Okay. That's all right. I'm going to use Amanda's.
Oh, you can use mine if you want.
Well, she's already on there.
Oh, that's a, that's a good
Oh,
one.
she's already got the test on here. Look, she already copied the test on it. Wow.
Okay, let me just tell you how to.
No, can you get me on Safari or
Yes,
something?
yes.
This is cool.
It's just like mine.
Yeah. Oh. I've already
That's
watched
here.
those. We can do this. Okay, so I want to log in. Amanda, I'm in Amanda's account. Don't want to do that. Amanda, I want to get out of your account and log into mine.
You just made a withdrawal out of your bank account.
Yeah, you have no more money.
That's another story I gotta tell you.
Oh, really?
How that happened one time.
Oh, I don't know how to get out of this.
Oh.
Let me see.
It should be.
Because I did it once just for your class. That's why I never had one before.
Yeah. Shoot. All right, I may not be able to do this. If we can log out of this.
Oh, I
and-
got it.
Oh, you got it?
Yeah,
Sign out. Okay, now I'm going to sign in mine. problem is I never sign into mine. It's already signed in, always. It's not funny. Wait, are people packing up ready to go? Jimmy, what are you doing? Oh, man.
Double laps. Don't forget to do that thing though. Remember?
Oh, yes, it's true.
Yeah, Professor Burns, I was going to ask, after we're done going over the test, you're just kind of generally going over the Mathematica.
I'm going to go over the Mathematica lab in a couple seconds. As soon as I get to this. Okay, now. Okay, I'm in. All right, that surprises me. Okay, now if I can scroll down here. Okay. And then if I go here, and then if I go here, and then if I go here. Oh wait, you don't have Mathematica.
Oh yeah.
It's all written in Mathematica. Oh, nuts. I'm sorry, we can't do it. She doesn't have Mathematica.
Sorry.
You got Mathematica? You got yours? All right. Now, I got to sign out of my account because there's all my tests.
Is it shown?
Well, come here.
Here,
She doesn't have Mathematica. She can't even.
I can't even look it up now.
See, but you gotta log me out.
I will, don't worry.
All right, I trust you.
Here, see, just to show you. Sign
I
out.
believe you.
All right.
Sign out. I
I
believe you.
didn't want to do that, but I just did.
Honor code.
Yeah.
You're leaving me? Oh, man. Okay, if you can get me to Safari or any browser at all, I'll be able to get in there. Yeah. Caroline, what are you doing? Okay. So you like
I did, I swear, I promise.
Oh, there you go. We don't need Mathematica. Well, we are going to need
player.
it.
You ever use a CDF?
Yeah,
No,
once
you
or
didn't.
twice. But I don't.
All right.
I want to go to Dropbox.com. www.dropbox.com.
Like his laptop is still like at his desk.
I've never been there. What is Dropbox?
Dropbox is something you buy to store all your files on the cloud. Yeah, you can get free 5 gig or 10 gig or something.
Why didn't you use your iCloud?
Because I don't like iCloud. Dropbox is better.
It is?
Yeah, it is better.
How about Google Drive?
I've never used Google Drive.
Google Drive's nice. It also makes it so that you can view.
I've been using this for years and years and years for all my photos and stuff. So it's what I use.
Well, I feel like Google Doc is better. Google Drive is better for documents and forms for that. So
Really?
I'll use Dropbox for photos any day.
There we go.
That's, do you run that on the Mac?
Kind of.
Because Eddie Biggest doesn't run it too.
I'm running. It's on an old Power Mac. It's headless, so it's not really a boot. It's a server software. And there's no desktop.
Ah.
No.
This is my applied Mac. 255. Okay. So, test 1, right? That's the test of getting money.
Oh, I thought you were going to show it.
Oh, I am going to show them on a second.
Yeah, all you got to do is poke the HDMI right in there and switch.
Okay, why, Jimmy, where's mathematics? You got mathematics
It's right here.
So,
Either way.
and it just opens. When I double click on it on mine, it just opens it. It's a notebook.
Oh, it is.
Yeah, it's a .nb file.
Oh, start mathematics.
Mine just opens automatically.
Yeah,
I know, but-
Lord, all mine on here that are mathematical files. Can you drag,
Yeah.
just drag that, that's,
Yeah, that would be good.
yeah, photo like that.
If I could do it, share, download. There it is, there it is.
Right.
All right, there, double click it, should work. There it is. Okay, I have it. I have your test. So, here you go. So 2 grade each. Give the integration form. Now, here's what I have. I have 1 over u, no du, no integral. It's just 1 over u, or u to the n, or inverse tangent u, or inverse sine u. That's it, u to the n. It's just that, okay? That's exactly what the form is. Everybody understand?
Did you write that down?
Yes, I can. Thank you, Jim.
What do you want?
I'm gonna write it down.
All right, on a piece of, if you need it on the notes. All right, we need it on the notes. I'm going to do it live in a second. We can do it on yours.
Go ahead.
So, out of all these, this is the form, okay? That's what I have. Or this is the form. When I ask you the form of the integral, this is what I have, u to the n. No u to the n du, or the integral of u to the n du. It's just u to the n. All right, you can leave that here for a couple minutes. I got a couple more to do. This would be great. Okay, you ready? All right, let's finish this. Ready? Yeah. Okay. So, I'm doing,
I'll just close the top and then it'll open it up.
okay. That was number,
16, so 17.
okay, we're doing 17 now?
Yeah.
Okay, here's 17. The integral of 1 over 1 plus x squared dx. What form is this? Which one? Inverse tangent, thank you. Okay, that's the answer, inverse tangent u. Okay, that would be the answer that you want to find. 18. The integral of 1 over square root of 1 minus 9x squared. The integration form?
1 over the square root of 1 minus 3x squared.
Yeah, but what's the integration form?
Arc sine.
Yes, that's the answer I'm looking for. Inverse sine. Okay? Everybody else set on that? Okay. All right, yours and your test may be different, obviously, but it's along these lines. I wouldn't give him an RC can. We generalized it now, but I probably wouldn't give it to him. Yeah. I care about these people. All right, population of mosquitoes. Oh, look at this. This is Zika stuff, right? Zika virus? Mosquitoes? You guys didn't? No.
Yeah.
Okay, but anyhow. Increasing at a rate of 20% per day continuously if the initial population. So here's what you have. P is equal to P sub naught E to the KT. I would expect you to know that. Okay? You should know that. So what do we know? P is equal to initial population is 1,000. The rate of increase is 20%. Okay? 0.20, 0.2 T. That gives you the population at any given time. The population at T equals 7. Okay, E to the, and put a 7 in for the time, so it's 1,000, E to the 1.4. Now, do I have it like that, or do I have a decimal? I think I have it like that. Is it still here? Yes. Yes. Oh. 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 This test is a little bit different. I'm going to make up a new test, actually, is what I'm going to do anyways, but it's not on this test like that, but it will be on your test. I probably have the answer just like this. What's that? Okay. And then I asked for doubling time.
Now, I'm guessing I made the error. You didn't want us to do t of 14, because that was my interpretation from the way it said that.
Say that again?
The doubling time was not that t equals 14. That was not what you were implying when you said doubling time.
Doubling time is what I'm going to do right now
To get to 2000.
to get to 2,000. So divide by 1,000.
So you're looking for the time at which the population doubles?
That is exactly correct, Karen.
Okay, I was confused as well.
You thought
Okay.
you did double time. I was like, oh, this is easy. T equals 14, exact same thing.
Oh, no. It's time to, just what Karen said. She said it perfectly. Okay. You need to find the time here. To find the time, take the natural log of each side. Natural log of 2. Natural log of e to the 0.2t is 0.2t. You want to solve for t. This is 1/5 multiplied by 5. The answer you'll see on the test would be t equals 5 natural log 2. Okay? That would be the answer. Okay? That's your test. How you doing? Okay. All right, let's do the lab. Question?
1,000 e raised to the 14th or 1.4?
1.4. It's 0.2 times 7. All right, let's take a look at the lab. He's already got it on there.
If we finish the lab, do we just email it to you, or do you want it to print it out hard copy?
I want you to email it to me as an attachment. Actually, I'm not going to use his. I have it here, and I have the cord that I need, so I'm not going to use his.
Class on Monday is regular length, right?
Yes.
It's not like you take the test and you grade it or whatever.
Here's what happens on Monday. Come in, I'll pass out the test. You bring it up to me, I will correct it. You will leave for a while until the last person is done. Okay, when the last person is done, you'll come back in. I'm going to go over the test. This is when you have possibilities for partial credit if your work is essentially correct but you got something wrong. And then generally what I do is start the next chapter. That's my plan right now. Okay, that's what I'm doing. Okay, do we have... I'm not done. I'm going to go over the lab. What, that's still on?
Sorry, then,
No. Make sure it's still, yeah, we run it on because I want to show you the lab. Okay. 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 Wow, I lost people left and right there, huh? Okay, so. Okay. Great. Okay. So this will work. It has worked in the past.
Did I mess it up? I think I did. I don't know.
I don't know. Leave that alone. That's S video is not what we want. That's for sure. I know there's a menu on that thing too, but I hate to mess around with that. We shouldn't have to mess around with that. Oh, but boy, this is getting us nowhere. Hold on a second. Let me just turn try shutting it off. I may just have to show you from his. Last year, well, we had it working, right? It took us a while sometimes, but it always did work. I don't know. This is not working right now.
Oh, yeah, we had lots of fun last semester.
Well, it eventually worked all the time, but this is getting us nowhere. All right, I'm going to just show you it.
Oh, wait, what's the
Hopefully you
dongle? This is the dongle again.
Possibly.
And
But that thing's not changed. I can't even shut that thing off. The thing is not moving
where's
at all. And I don't want to spend a lot of time on it because people are getting really itchy. You can see that. Whoa!
Wait. I think I don't remember what this is set to. I don't remember what because I want to pick up the dock cam again.
Okay, you want to do the dock cam again.
I want to pick up the dock cam.
Wait, did everything get switched up there? We don't want to be. All right, hold on. HDMI.
It's good. You got it.
All right, that's the document camera. Now I've got HDMI here, and that should, because I plugged this in. Hold on. This is going to work. I didn't realize that was switched around.
Yeah, change test video.
All right, hold on. Okay, hold on. Takes time. Yeah, it takes some time. Oh, you're going to go underneath again?
No, I just want to make sure it's connected to the right slot. Then I think it's connected.
Oh, cool. You know what? That projector's not even on, is it?
It is.
Is it?
It went to sleep because
Went to sleep?
it doesn't recognize it.
All right. Well, I'm gonna do it this way.
Can you get up and look at it, or?
Oh, we could do the thing I did last time, which is a little questionable.
Oh, put it underneath there, like? Do this.
No.
Watch this.
Watch this.
Watch this. We can do it.
No.
I got it. I can do it.
Give me the dongle. We can do this again.
We could do it.
Okay. You're gonna need to. Yeah. There you go. That should do it. Oh, fingers crossed.
Okay.
Yay! Woohoo!
He's the man.
Yay.
He's the man.
Extra points.
Yeah.
Tons of extra points.
Wait, did you say 20?
At least. At least. All right, here we go. Okay, the lab. First of all, you should have the lab, either because I sent it to you directly or get it from the Dropbox connection that I sent you. If you do it correctly, you should be able to get it that way. Otherwise, if you can't get the lab, send me an email. I'll send you all the labs at once. I'll just send them to you directly. They also are on the stick.edu/math, okay, labs, and all the labs are there. I've changed them over the years, though, but this one I think is pretty much still the same. So you could get it that way. Okay, so let me just go through this a little bit. In Mathematica, this is the document here. It's broken up into cells. Let me just give you an introduction to Mathematica here. This first thing is a subtitle cell. If I go to Format, you'll see that it's a subtitle. This is a subtitle, which means it's text. Mathematica doesn't care what you put in there. It's just text for a human being to read. This next cell is also text for a human being to read. The format would be like a subsection or something like that. It's a subsection. Mathematica doesn't care what you put in there. The only thing Mathematica cares about is what you put in an input cell. This cell right here that I've selected is an input cell. That's given Mathematica something to do. So what I've done, I've written this code, typed it in, hit the return after each line. What I've done is defined a function, square root of x. This is the syntax for defining a function. You guys are not going to have to do this, because what you're going to end up doing is copying everything that I wrote, paste it down below, and then change like one thing. So you won't have to do this whole thing, but I'm going to go through and just kind of explain what I did here. Okay, I defined a function. That's the syntax for defining a function in Mathematica. I set n equal to 8. The semicolons at the end suppress the output. So when I run this cell, it doesn't just repeat n equals 8 or 8. It just ignores it, the little semicolon at the end. A, I'm starting at 0, that's my left endpoint. B, I'm saying is 4, that's my right endpoint. N is 8, it's the number of rectangles that I'm dividing the area up into. I'm giving it the increment, which is b minus a over n, okay? I'm telling it to plot the function. Plot style thick makes the line thicker than usual and label the axes x and y. If you don't, it doesn't label the axes. I'm plotting a table of graphics rectangles, okay? So I'm telling Mathematica, go along this interval from 0 to 4 and divide it up into 8 rectangles. This line right here, this table, is making a set of 8 rectangles, okay? Then I'm telling Mathematica, show me what you've done. Do the show, do the plot and the rectangles together. That's what you're looking at here. This is the show statement. It's showing me the plot of the function and the rectangles, P1 and P2. Then what I'm going to do is calculate the area, the approximate area, by summing up the areas of the rectangles. If you've done any programming at all, you know this is a typical kind of a for-next statement which adds up things, okay? It's an accumulator. It adds up the areas of each of these. F of x sub I would be a left endpoint or a right endpoint times the increment, and add it to whatever AA was to begin with, and that adds up all the rectangles, okay? Then I'm saying give me a numeric answer with 4 decimal places. That's what this does. N tells me to make it numeric, tells Mathematica make it numeric. That's the approximate area. Area approximate. This is the area exact, is the integral. Okay? I'm telling Mathematica do it as a number, integrate from A to B of my function, whatever it is, and give me 4 decimal places to compare it. And then I'm saying print rectangles, approximate area, print the word exact in quotes there, and the exact area, and then give me the percent error. Take the difference, divide by the exact, times 100%. Okay? So it's giving me what the error is. So by doing this and running this cell, this is what happened. It gives me the function, the rectangles, the rectangles give me an area of 5.765. The exact is 5.333. The percent error is 8.1%. That's with 8 rectangles. Now, if you want to get a better approximation, increase the number of rectangles. Instead of 8 rectangles, let's go to 100 rectangles. Okay? If we go to 100 rectangles, okay, this thick line means it's running, it's calculating. Okay, it's calculating, doing stuff, adding things up, calculating stuff.
I have a question.
Yeah, go ahead.
The more rectangles you put, does it give you like a more accurate answer?
You bet it will. You'll notice our percent error is going to decrease if it ever gets done doing it. Okay? This is absurdly slow right now, though.
100 was a little too much for it, maybe?
You know, that is a good... I just did this with someone in my office with 1,000 rectangles. And it just did it almost immediately. Oh! Was not able to start due to licensing terms. What the beep are you talking about? Okay, hey, whatever. All right? I have no idea what that's talking about. So it won't do the 100 that I just did. Okay, you're going to have to trust me in this. What it would have done is made a nice, the graph is the same, and it would have made 100 little rectangles in there, and it would be almost exactly filling in the area. It would be like totally exact. Carlos?
Can you make a little bit more program? You know, instead of putting the line and refreshing every time.
Say that again now? What?
Can you make a slider so that every time you move the slide will increase the...
You could use a manipulate statement to do that, yes. And if somebody were to do that, that would give them big points on the extra credit, Well, here's what you're going to have to do. You have two things to do. Apply the above to f of x equals sine x from 0 to pi. So here's what you're going to do. Okay? You're going to take this code that I wrote. I don't know what it's going to allow me to do right now. Okay, but I'm going to see if it'll at least do this. Copy it.
The whole thing?
Huh?
Put it on paper.
This part of it right here that I just did. Okay? And you're going to copy it, and you're going to come down here, and you're going to paste it in there. At least they'll let me do that. Okay? And then you're going to replace this. Now, I had 8 rectangles to begin with. Wait, let's see if, will this run? It won't run. So it's running, but it's instantaneous. When the first one worked, this one, I don't know. The license must have expired at exactly like 8 o'clock or something like that. I don't know. I have no idea. Okay? All right. So anyhow, you've got your Mathematica, copy and paste like I just did. Now, instead of the square root of x, here's what you're going to do. Watch this now. Watch carefully.
Yeah, change the sign x.
Okay, I'm going to put the sine x in here. Now, when you put in a Mathematica function, it has to start with a capital letter. All Mathematica functions start with capital letters. When you define, we paid for this network, for this whole site license, okay? I have no idea why it's doing that. I've never even seen that thing, but that's okay.
So sign
What-
needs to be backwards?
What's that?
Sign needs to be backwards?
Yes, I'm going to put it in. Sine, and it has to enclose its argument in square brackets. So when you put in sine function, make sure you put a capital S and enclose the x in square brackets, okay? Because I know people are going to send me emails and tell me, Burns, your stupid lab doesn't work. Here's what I did exactly what you told me to do, and it doesn't work, you bozo guy. And it's because they put a little s or they didn't put square brackets, okay? So put the square brackets in there and run it. And just run it means what? Click somewhere and do a shift return or shift enter, and it'll run. Now yours will run and actually give you a solution, okay? Then what I want you to do is use a function of your choice. Use something besides sine. I don't care what you use. Use whatever you want, okay? Use something besides sine. If you do those two simple things, change that line twice and send it to me, that's a 90 if you do that on time. Now, how do you get a better score than 90 on a lab? Well, you could change the number of rectangles, which I tried to do before the stupid thing refused to do it. Okay, change the number of rectangles and do that and see what the error is. Okay, you could change, if you really want to get ambitious, you could change the A and the B part, the beginning, the left and the right. Okay, it feels like Night of the Living Dead, where your bodies are coming up and they're gradually, coming to life again,
I'm like,
and they're all going to come at me.
Drive home, I gotta go.
Oh, okay, go ahead. This is it, done.
Have a
Karen,
good day.
see you. Okay, and that's it. That's how you can get better than 90. You do something else. You do more general. You change the colors. You
Make it 3D.
Make it. If you make it 3D, that would be amazing. If you use manipulate statement and use sliders to do it, one of the labs later on, I'll show you how to use the sliders, but this is the basic lab right here. Okay, we understand?
Can we do that in like a second version and we do it as an assembly?
Yeah, you do this, what I just did,
Yeah.
save this to your desktop, and then email it to me as an attachment. All right, see you. Go ahead, Abby.
Wait, I made one of my projects. I had a 3D graph in it, and you only gave me like 3 points.
What's the
I don't know, I'd have to see it.
If we're gonna like change our N or like our A and B,
Yeah, yeah.
should we do that in the same one as the sign, or
No.
should we make another one?
You can make it up. You can make it up. You make several.
See you before we send it out.
What's that?
Can I show it to you like by the week before I send it out, like on Friday? Like on Thursday?
What do you want to do?
Show you whatever I done.
Can you,
On your computer? Just show it to me so you don't have to save it and send it to me?
No, so I could send it to you, but I want to send it right, not send it like having it not right.
Oh, okay, fine. We can do that. Thanks, Jacob, for that. What you did was cool. Go ahead.
Professor,
Have a good night.
See
I
you.
don't know if the slider's gonna do this. Last semester in Calculus 1, I used the same thing, but it started to appear that message, that it was unsafe.
No,
And I did.
do it. Just, it doesn't care.
Yeah.
It's dynamic. Anytime you use manipulate, it's going to tell you that. That's okay. Just ignore it.
So what kind of file it would be, the Mathematica that you did? The
Dot
programming?
.nb file.
Dot .nb?
NB.
NB, okay.
That's what it is. Save it to your desktop and send it to me.
Mathematica's been having trouble with licenses this year, by the way.
You know this, really?
Yeah.
I've
They've
never
been-
seen that message before.
Well, no, they've been having trouble with having people getting revoked licenses throughout, like, and if it keeps on persisting, sometimes you'll have to, like, renew your license or just give them a call and they'll give you another free one just to redo the download and stuff.
Really? Is that right?
sometimes.
Wow.
That's what we had to do in my lab last semester.
Is that right?
Everyone is having trouble with it.
Oh, wow. That's the first I've had trouble with that.
Yeah,
like that.
it's a new thing this year.
Wow. Okay, well, thanks for that information. All right. Wow, that was weird.
Yeah.
Do you use the new version of
No, I don't have the newest. I have 10.2, not 10.3. I should download 10.3 on this. I will tomorrow when I come in.
Because there is a command that I usually use. It's called random color, but it doesn't run on the old
Oh, you're
version.
still recording,
Really?
by the way.
Yeah.
What's that?
You're still recording?
Oh yeah, it's still recording.